Hi, everybody. We're starting section 2.5, the chain rule. Extremely important rule. And I want to give you a little motivation here. Um, so find the derivative of y is equal to 4 times x cubed plus 15x to the second power. Well, that second power is going to create some problems because we can't just come in and do a straight derivative. What we have to do is we have to multiply it out. I guess like FOIL it out, So 4x cubed plus 15x to the second power is 4x cubed plus 15x times 4x cubed plus 15x. And you multiply it out, you're going to get a middle term. And when you FOIL this out, you're going to get 4 times 4 is 16x to the sixth. 15 times 15 is 225x squared. The middle term is going to wind up being 120 x to the fourth. And when you take the derivative of 16x to the sixth is 96x to the fifth. But I want to point out the textbook has a typo. The textbook wrote 64, but I just corrected it by putting in a 96. That's really what it should be. Just pointing that out. And but the rest of it is correct. 480x to the cubed, because 4 times 120 is 480, and the x to the fourth becomes an x to the third. 2 times 225 becomes 450 times plain x, and that's it. So this wasn't so horrible. We got an answer. It's all fine. It's all good. But what if this 2, the second power, which made that made things a little more difficult because we had to start multiplying out. What if instead of a 2, what if that 2 is a 20? Imagine we had this problem right here. Y is equal to 4x cubed plus 15x to the 20th power. Oh, yeah. How are we going to handle that? Well, we could multiply things out 20 times, but oh man, that would be a massive, massive, massive pain. So that's where chain rule to the rescue. Chain rule to the rescue. So I'm going to show you what chain rule is officially, and then I'm going to actually come back and solve this problem we just did using the chain rule. In fact, chain rule is going to be so easy that we're even going to do the 20th power guy, but let's just get this first. So y is f of u, where u is g of x. So this is called a composite function. Y is a function of y is equal to f of g of x. So the chain rule in the Leibniz notation is dy dx is equal to dy du dx, which is kind of cool because it's almost like the cancels out like the fractions. That's kind of cool, and kind of seems that way. And I like this. It can remind you how the chain rule chains together. I like that. Anyway, the other way of saying it is that f prime of x is f prime of u times g prime of x, or you could say f prime of g of x times g prime of x. Now that looks very complex when you look at it, but it's really actually not difficult at all when you actually do the problems. But a way to say it is that the derivative of a composition is the derivative of the outside with the inside staying the same times the derivative of what's inside. Now, I just want to say from a common sense point of view, chain rule kind of makes sense because it's like if you run twice as fast as me and I run 3 times as fast as Bob, so you run 6 times as fast as Bob. You see what I'm saying? That in a way is kind of like chain rule. That's kind of what chain rule is saying. Anyway, let's now work on an actual problem. So for that, I'm going to switch cameras, and I'm going to go to my little pad here, and we're going to work some stuff out here. All right, here we go. So here is section 2.5. And we're going to do the same exact problem that we just did, the same exact problem we just did by multiplying it out. Now we're going to do with the chain rule. We've got a little fuzzy here. Very good. So y is equal to 4x cubed plus 15x to the second power. So this here is my u. So u is equal to 4x cubed plus 15x squared. So this quantity, what I'm doing is this whole quantity, I'm taking this whole inner quantity as a unit, taking it as one unit, and I'm going to take the derivative of this big giant unit. So y prime is equal to 2 times this inner quantity. I'm just going to write 4x cubed plus 15x. So just like the derivative of u squared is 2u, so the derivative of this blob squared is 2 times that blob. Now times the inner derivative, meaning the derivative of this blob, this inner blob, and 3 times 4 is 12, x to the second power, and the derivative of 15x is just 15. And pow, that's our answer. That's it, we're done. Got the answer. Now, I just want to show you, just for the sake of completeness, the answer that we just got that I wrote here does not look like the answer that we just saw a minute ago in the textbook. So I want to show, so really we're done. This is the answer, we're done. Let me put it right there. You finished the problem. But just for the sake of showing the consistency of these different methods, that even though you have different methods, you still get the same answer. I'm going to go an extra mile here, an extra yard, or whatever the expression is, and I'm going to multiply this out to show how this is going to be the same as what we got in the textbook. So let's just do it. So let's start here. 4 times 12 is 48, times 2 is 96. And it's x to the third times x squared. That's x. That's what am I trying to say? That's x to the fifth. Okay. Now, that's the first inner. 4x cubed times 15 is 60x to the third times 2, so it's 120. 120 x to the third. And then 15x times 12x, well, 15 times 12 is 180, times 2 is 360. Again, x to the third. And 15x times 15 is 225x, times 2 is 450x. And when you just combine these like terms, y prime equals 96 x to the fifth plus 120 plus 480 x cubed plus 450 x. And this here is the exact same answer that we got. In fact, let me just show you. This is the same answer that we just got in the textbook. Let me just show you my screen. You should be able to, hopefully you can see it. Let me just show you the right camera here. So this was the same answer we just got. Yeah, 96x to the fifth plus 480x to the third plus 450x. You see, we got the exact same answer. So this stuff really works. Okay, now let's go back back to the paper, and we're going to. I want to do. Remember I said before. Oh boy, if this was the 20th power, wow, really be hard. Well, with chain rule, it's not going to be hard at all. It's going to be very straightforward. So let's look at a new example. Let's look at y equals 4x cubed plus 15x to the 20th power. I just want to. So y prime, well, it's going to be the inner derivative. So it's going to be 20 times the blob to the 19th power times the inner derivative, which is 12x squared plus 15 pound. So this is the this is the outer, and this is the inner. So we have the outer derivative and the inner derivative. This is the derivative of that outer function, the u to the 20th power, and this is the derivative of that inner function, that which is inside the blob. So it all works out very beautifully, very beautifully. Let's do another problem. Here we have uh, y is equal to e to the x squared plus 5. So the outer function is, e to the u power. That's the outer function. The inner function is x squared plus 5. So e to the u is the outer function, and x squared plus 5 is the inner function. So y prime, first I take the outer derivative. Now the derivative of e to a power is just the same e to the power. So it's e to the x squared plus 5. That is the outer derivative. Times the inner derivative, which is 2x. Because the derivative of x squared plus 5 is 2x. So I'm outer, inner, and power. We're done. That is beautiful. And by the way, I just want to point out, in this top problem here, we could have multiplied the whole thing out and done power rule. Would have been a real massive pain, but we could have done it. But this one, I can't multiply this out. It's a e to a, it's an exponential function. I can't just multiply it out. E is an irrational number, so so the chain will really save the day, and you know, in a major way. Here's a nice problem. Y is equal to the square root of the ln of x to the fourth plus 3x squared plus 7. Well, this looks very hideous and horrible with logarithms and big radical signs, but really it's not. With chain rule makes it really it's just going to be very straightforward. So the outer function is the square root, and we know that the derivative of the square root is 1/2 square root. So so first I'm going to do 1/2 times the square root of ln x to the fourth plus 3x squared plus 7 times the inner function. The inner function is the log function, and the derivative of log is just 1 over whatever is inside it. And then finally, I have the inner function, which is this x to the fourth plus 3x squared plus 7, and that derivative is 4x cubed plus 6x. Which, by the way, this is what I wish for all of you. I wish you much success. You get it? See what I did there? So again, this is the outer function. That's the inner function. That's the inner function. That's the outer derivative. That's the inner derivative. And that's the inner derivative. So that is how now, and that's it. We're done. That's our answer. This here is the answer to the problem. Pow. Look at that. There we go. So even as hideous as it was, it didn't take us more than a minute, to get the answer. So that's great. Let's, maybe it took me, and the only reason it took me as long as it took me is because I had to be explaining everything as I was doing it. But you'll see, you're gonna get the hang of these. They just go zip, zip, zip. Chain rule makes things so easy. It's unbelievable. Um, let's let's go look at another let's do another problem or two. Here's a nice little problem. Y equals ln x plus e to the x to the 17th power. Well, again, this is going to be very straightforward. Y prime is going to be 17 times ln x plus e to the x to the 16th power times the inner derivative, which is 1 over x plus e to the x. And that's it. Now we're done. That's our outer, and that's our inner. And that's our outer derivative, that's our inner derivative. Beautiful. Now I want to just do one very kind of simple one, but it's important. Another example, very simple example, but very important. E to the 3x power. That's it. Y equals, well, y prime is going to be equal to e to the 3x power times the inner derivative. What's the inner? Well, the outer function, again, the outer function is e to the u. That's our outer function. The inner function is u equals 3x. So I have to multiply this times 3. So again, that's my outer, that's my inner, that's my outer derivative, and that's my inner derivative. And this is pretty important. This is pretty important. It comes up quite a bit. Interestingly enough, what if we did ln of 3x? This is really interesting. If y equals ln of 3x, so my guess would be, if the derivative of ln x is 1 over x, so my guess would be that this is going to be like 3 times 1 over x, or 1 over x times 3. Shockingly, that's not going to be the answer. The answer is going to be more streamlined. So let's just do it. Y prime is equal to the outer derivative, which is 1 over 3x, times the inner derivative, which is 3, but then the 3's cancel, and this just becomes 1 over x. Isn't it amazing that the derivative of ln 3x is the same as the derivative of plain ln x? That's amazing. Why would that be? It doesn't make any sense. Well, actually, it makes a lot of sense. Because if you remember the laws of logarithms that you learned in, when you took, I don't know, college algebra, when you took algebra, you learned the laws of logarithms. And ln of 3x is equal to ln 3 plus ln x. Now, when I take the derivative, well, when I take the derivative of this, ln 3x, ln 3 is just a constant, just a number. I could look at it up on a calculator, whatever it is, 1 point something. So that just really disappears. And then ln x is 1 over x. So the derivative of ln 3x is just plain 1 over x, because that's the magic of logarithms, that when you multiply inside a log, it's the same thing as adding on the outside. Or we did it with chain rule and everything canceled out. So this is quite remarkable, and quite beautiful. Okay, let's look at another nice little problem. I want to show you two nice little problems here. They're similar looking but different. And the difference, of course, is the parentheses. Let me just delineate that. So here I have the ln of x squared. Here I have the ln of x squared. But really, really there's a parenthesis here. I didn't write it, but really there's like a little parenthesis in there. It's the ln of x squared. Now, let's do this one first. So y prime is going to be the outer derivative, which is 1 over x squared, times the inner derivative, which is 2x. So again, that's my outer, that's my inner. But this actually cancels, this reduces to 2 over x. And I just want to show you that we could have done this problem actually a little bit differently. The laws of logarithms tell me, let's write the whole problem over. Y equals ln of x squared. Well, by the laws of logarithms, this is equal to 2 times ln of x. That's a rule of logarithms. So y prime is just going to be, well, it's 2 ln x prime. And that's just going to be the derivative of ln x. This is just derivative of ln x is 1 over x. And the 2 constant, just as we said before, it just goes along for the ride. So I get 2 over x. I get the same 2 over x. So we see we did this problem 2 different ways. This was not done with chain rule, it was just done with some algebra rules. Anyway, now let's go to this one. This one here is, even though it's similar, they both, when you say it, it's ln x squared, but it's, a different squaring. So y prime is going to be the outer derivative. Now, the outer derivative is going to be this blob squared. So the outer derivative is going to be 2 ln x. That's my outer. The inner is going to be 1 over x. So that's my out, and that's my in. That's my outer derivative. That's my inner derivative. And I'm going to put parentheses here just so you realize that it's not the ln of x times 1 over x. It's the ln. It's 2 ln x, and that whole quantity is multiplied by 1 over x. And that's it for part 1. I'm gonna continue the part 2 video, and I will see you guys next time. Bye.